Yeah. All okay, Dave. Carry on.
Right, there we are then. Right. So this is a talk by me, G40YX Dave. Simon hyped me up to be the chief engineer at Wooferton. I haven't quite got claim to that. I was a senior transmitter engineer for 30 years there, with an occasional bit of acting to be engineer in charge of Wooferton and Orford Ness. So I did a couple of 3 years of that in the middle of it. Anyway, from V2 rockets to the voice, the first 20 years of Aussie 10. Now, these slides are put together by Duncan, who's M0OTG. It was due to Jeff Kant, who wrote an article for a magazine, and he described exactly what we're doing here, the first 20 years of Aussie 10. I gave the slides to Duncan. He put them down literally. So they're not in perfect timed order. So we'll bop about, and you might have a few of more recent slides of Aussie 10 than the first 20 years. Station was built in 1943. So the first 20 years would obviously be to 1963. Here we are. So this is how it looks now. Lot of satellite dishes around the outside, an electric gate, and the sign there that says Encompass, Wooferton Transmitting Station. It was sold by Babcock to Encompass, which is an American company, and they move program all around the world, and that program can be on sat, on fiber, on file transfer, anything like that, as well as on HF. This is the one of their HF stations. The other one they've got is Ascension, is operated by Encompass, as is the engineers are all operated by Encompass at Al Diabia, which is United Arab Emirates. And I think they also run the engineers at Arsila, which is in Oman, but that's a BBC transmitting station. It's the way it works between the governments. But that one is but the engineers are run by Encompass. So that's the outside of Woof, almost the same as when it was built. There's a few extensions gone on, and of course a few satellite dishes. Here's the view from the top. Please shout out anybody if the audio stops or the pictures stop. So this is the top view. Looking down, you'll see a bit here. If you can see my slide, you see my arrow moving. This was the original building, put up about 1941 and a bit, for the contractors to live in while they built this lot, which was the main building. And that got finished on the 17th of October 1943. It made its first transmission, 6 transmitters in there, and diesel generators at the bottom here, and officers and control rooms and engineering at this end. But there was an emergency control room in this section here in case it got bombed. There are a lot of brickworks around the building. This area here is labelled what part of this is labelled an air raid shelter, because they were fearful that it was going to get bombed in the Second World War. Oil storage tanks are in the field, and a transfer station there to get the oil into the diesel alternators. There's the feeders going out of from the transmitters, 328 ohm balance down the field, and there's 4 screen feeders here you can see to antennas that are nearby. There'll be probably more on that later. So that's the above sky view. Here we go. Classic line of masts here. This is the sort of standard picture that punters take from the road. This is the bearing on these masts. If you work the bearing out, and remember when we have shortwave arrays, they hang between the masts. And so bore sight here, these are all the 74-degree ones. And on the other end of 74 degrees is Moscow. And if you slew it a few degrees one way, you go to St. Petersburg. And if you slew it a few degrees to the other, you go to Kiev. So an important set of arrays, much used, of course, during the Cold War. Aussie 10 was the last of the BBC stations to be built during the war. And Aussie stands for Overseas Service Extension, OSE 10. Just to go through the numbers, Aussie 1 and 2 was the extensions at Daventry to the main building, was the east end of Daventry, and the west end when they built the main building away from what was the little building that had the two shortwave senders in when it first kicked off. That was 1935, 6 or 7, no, about 1935. That was that was the first one, Aussie 1 and 2. There are 3 was Rampersham in Dorset, 1939, came on the air. Aussie 4, can't remember, probably Lisna Garvey with a shortwave added for the war. Aussie 5 was 4 200 kilowatt long wave or medium wave transmitters at Ottringham on the east coast near Hull, straight across ground wave into Germany. They actually ran 3 200 kilowatts to give 600 kilowatts on long wave, various frequencies in the band. And the other one was on medium wave, 767 kilohertz, closed in 1953 when the money ran out. That was Aussie 5. Aussie 6 was Droitwich, the extension at Droitwich to 2 200 kilowatt long wave transmitters, no, medium wave transmitters. And that went in at Droitwich. Aussie 6, Aussie 7 was probably Clevedon. 8 and 9 were Skelton A and Skelton B in the 1960s. They were called Aussie 8 and 9 up in Cumberland near Penrith. And they had Marconi transmitters in 8 and ST and C transmitters in 9. People often used to refer, old timers, oh yeah, I got sent to 9, I got sent to 8 and 9, or I got sent to 5. You wouldn't say Aussie, you just say the number. And of course, Aussie 10 was the last one, Wolf. Here's a quick up-to-date shot. I told you they jump about a bit. This is the new control room, installed 2007. Martin Gould in here, he's 2E1EKX. And it's all screens these days, of course, and auto transmitters. So no more wave changing by lifting coils out and tuning them up manually. You have to hope the electronics works for you. Scheduling is done by a thing made by a firm in Stone called Capula. And the schedules are such that the details of when they're on and off and what times and what days of the week and what frequency and what antennas are required are all compiled in London in schedule unit, or whatever they call them, schedule frequency management, it's called now, SFM. And they can just email the schedule. The schedule just comes up and gets loaded straight into Capula. And Capula will then present you with a new schedule. We don't have to transfer it from either memos or lines on text or pieces of paper or teleprinter messages. It can all be done in London. So that's the new control room. Here's got me back on the geography. Here's the site. There's Wooferton on the right-hand side, and the B4362 here. And you've got the main building here, then switch station 1A, switch station 1, switch station 2, switch station 3, switch station 4. So all the antenna feeders for that area come into 4 and then hit a matrix here. And there's the main feeders going up and down that you saw on the first picture. This mast nearest the building has got FM radio on it, 107.8 local radio. And there used to be a medium wave antenna slung from this one here for Radio Hereford and Worcester, and before that Radio Shropshire on 1584, but the BBC have turned all those off. 37 antennas and about 36 masts, something like that. So you don't see all the masts on this Ordnance Survey presentation. This direction here over Richards Castle is North America, Central America, Caribbean, South America this way. As I told you, you've got Moscow over here, straight from this line of masts here. Obviously, you can do it again from this set here. If you use this one here, that takes you to Italy, that part of the world. These here, these two, that's straight down, which is Gibraltar, then into Morocco. And then if you go further, you get to Nigeria. If you do something from here in this direction on 21 megs from this one here, the 3 antennas here, 21, 17 and 15 megahertz between those two masts. But if you do one there on 21 megs, it will go to Australia. It was done recently on 21 megs with DRM, and it was almost broad. It was CD quality audio received on shortwave by digital radio from array 901 on 70 degrees in the daytime. So that's the sort of setup of the masts and the bearings that run. Okay, what you really want on a shortwave station is this, and this is probably why this station lived to tell the tale to become the last one in the UK when they shut the rest. Daventry was on a hill, as was Rampisham. Rampisham worked slightly better than Dav because it was more southerly in the country. It was near Bridport in Dorset. Daventry was on the hill and did not get a water table like this. Skelton didn't have a water table, but it was up north, out the way. But here, the water table is normally about a foot below the surface, so it doesn't take much rain before it appears, and it's a superb mirror for the HF antennas, the operation of the HF antennas. So there's a flood in 82. This has exactly happened only a few weeks ago. In fact, it was worse a few weeks ago. Here's the station being built, 1943, the earliest photograph that Jeff found. And you can see the coils of cable, etc. By the time this was built, it was the end of the run. So it's the most utilitarian station. Rampisham is faced in Portland stone, as was Daventry 1 and 2. Aussie 1 and 2 were beautifully built. But by the time they got to this one, and Skelton was a bit utilitarian, and this was extremely utilitarian. There's no plaster on the walls, it's painted bricks, and the skirting boards are painted on. It's much cheapness, but it's survived and it's running now. Here's we're back to 1979 now. There was one tower on the site erected then to take this new 4-band array. This did 9, 11, 17, and 21 megahertz 4-band bore site, and you could slew it 30 degrees off the main beam to cover different countries. And of course, very versatile, lots of frequencies and lots of bearings. The only problem was it was a little bit close to the main road, and they lost their bottle and wouldn't power it for fear of upsetting cars and drivers and everything else. So the antenna was taken down. This is array 952 TCI American. This was a big spend in the 1980s, beginning of the 80s, by the BBC and the VOA. The station was given money by the Yanks, and up to half could be spent in the UK. They'd like it if you'd spent all of it in the States, but in the end, they spent half of it in the UK and half they spent with American antennas, and here's one of them. So this was 952. It was dismantled, and it was used for spare parts then to keep array 953 going, which is next door to it. So that was quite fortunate. That 953 wasn't so near the road as this one. But when I got to Wooferton, that tower was there. But a few months later, it was dismantled. The array had gone by then; it wasn't available. Here's another shot of a mast. As Duncan says, which one? I can't tell him that, but you can see how it rests on the point on the ball bearing. And then you've got the spreaders here to keep the curtains apart. Okay, let's go back in time to look at the 1940 sender. When the station was built, it being the runt station and it having a high water table, there was no chance of digging a crypt to put the cooling plant in, as was the custom at all the other sites. So they had water-cooled transmitters, but no crypt needed. And they came from came on Lend-Lease from America, RCA, common modulator, and 2 RF sections. But they never got the RF sections for the other halves. They got the cabinets, but no insides. So they got 1 RF section and 1 modulator, and that's how they ran them. This is Center 86 in the top corner of the building, control desk here. And this is what it looked like in 1977. That's that one. And these were the two that remained from the installation in 1943. This pair, 85 and 86, were removed in 1979, and new transmitters were put in, as we will see in a bit. The stations had quite a few refits over the years. The original 6 of these RCAs were installed in 43, sender 81, sender 82, 83, 84, 85, 86. They didn't last very long, the first 3. They were taken out in about 1944 and removed. Where did they go? It took us ages to find out. They were taken to Crowborough by an RAF team. They knew that much, that it was an RAF team, but they didn't know where they went. But we found out they went to Crowborough and they were used as it was suspected that the V2 rockets that had been discovered, they'd found one in Sweden and it got radio control in it, about 30 odd megs. So they took the transmitters away and converted them to jamming transmitters, thinking that might stop the V2 rockets. In the end, it was only a prototype rocket that had been found, and the regular V2s, hence the title of this piece, were not radio controlled. And the transmitters were returned. Pat Hawker was one of the engineers, G3VA, who took them out, and he also brought them back. And they came back, but not all of the bits. Sender 81 was definitely missing a lot of pieces, and that was bodged to create a 50 kilowatt. These were 50 kilowatt transmitters. So this was a last station, and it had the smallest powered transmitters. The others were 100 kilowatts, but these were 50s at the other stations. So this what really was a little runt station. You can see the substantial brick walls on the building and a roof that would blow off easily if it was bombed and be replaced. You can see the output feeder on supports going out inside the building. 328 ohm balance feeds on the inside, not permitted nowadays. A, it's not screened, and B, you wouldn't have it inside. Excuse me. There's the clock. GMT Gents Leicester, as he says, one of the most important pieces of kit you can have on a station. Always on GMT, and the master was in the control room, and it was checked against the pips 7 times a day. LF Ivan was the first engineer in charge. Lawrence Frederick Ivan. I wrote an article recently and wrote that he ruled with a rod of iron, which he did for the first 20 years. He didn't take any notice of edicts or senior staff from London, just ignored the lot of them and did what he wanted to do. One of his printable phrases was, he was in short trousers when I was JME at Daventry, brackets, in 1928. So he knew his bits, but he wouldn't take any notice of higher beings. Back on the arrays, this is actually the bottom of one of the wideband arrays. You can see the switches and the feeders here go up to the bipoles. There's a periodic screen behind, sections of wire, and then the antenna itself is here, the wideband fat dipole. So this is a 1979 array, about £500,000 a piece, because you're not paying much for the metal. You're paying a lot for the expertise on knowing how to get it to work and build it in the first place. Not easy in those days. Computers had just come in. We looked at the matrix switches earlier, which we used since 1963. The antennas come in and then go out on a cross-point system. Before that was this remotely controlled antenna switching tower. About April 61, this is an original remnant from 1943. 6 senders in here, and then various antennas could be coupled up. It was like a big Yaxley switch, horizontally, but mounted vertically. Horrendous thing. And the young lads, the technical assistants female in the war, had to go in there to sort the switching out. Horrible place. Much improved when they got to matrix switching. Complicated hand switching this is inside that. inside that area to show you how you could get the different outputs of the senders to different certain antennas. Not nice. Looks like the tower was motorized, but you still had to set up the paths on the outside rim. Vile. I'm pleased to say I never saw that or had to work it. To get the different bearings and whether you want the antenna reversed or in the normal bore sight condition, it was all done by hand. And this could have been Daventry when I got there. It's actually Wooferton, but the procedure was exactly the same. And the RF came in at the right hand side here. This is Rod Vibash here. He was switching it there. He lifted the hooks off to put onto another one to get a different bearing or whatever. You can see some pinch matching here on the feeders. And Rod went on to become a senior maintenance engineer at Brookman. He went up to Brookman's Park to be an engineer, got promoted from TA, which he was here. And he went to Brookman's Park, and then he became an SME at Brookman's Park. And then he had been at Daventry for a while because he like me, he married a girl from Daventry. So he'd been around the houses of Rod. He's still over in Daventry now. He finished his career at Dav. Okay. Transport was provided from Kingsland because the base town was Leominster. I'll just take a drink. The base town was Leominster, and so the BBC hired a bus that brought the night shift, the evening shift in, and the day shift, and took them home again at the end. So that was the first bus in 43. Another one here a bit later on, when the base town became Ludlow, because the station's about halfway between the two towns. So a couple of vintage pictures there. As I said, when the station was built, it did have mains, but there were 3 reserve diesels in. Fred Goldsmith was the diesel driver. 1947. Jeff put during this post-war period, these engines were used to power the station for times when the public electricity supply was under great strain, as it was after the war. I've just done a piece for VMARS magazine and shown Tony Preedy putting these engines on in 1963 during the winter there. They're Harland and Wolff diesels, and I don't know who made, looks like, could be Brush, can't see. I don't know who made the alternators. There's an exciter at the end here, and then the main alternator there. So they generate at 11 kV, but I dispute that. I thought they generate at 415, but I'm not sure whether Tony, who wrote it up, quite got his facts right there. But what the heck, they're generated. And another view of them here. You can see H and W on the side there for Harland and Wolff. And as he said, the nearest engine to us does not have the turbocharger, which is there. There's a turbocharger and the one at the back, but this one hasn't got it fitted. There was a water on. Yeah, the windowless control room. This was the one that was, in case of bombed, it could probably still keep going. It was above ground within the building itself, but no windows. There's a TAF in here, technical assistant female, working the kit, and an engineer, no doubt, standing over to check that everything was ticking to boo. There's one of the gents' clocks. Most important thing was the clock and the loudspeaker, and then the jack fields, etc. So, and the program came in on post office lines. D-Day. The V1. Just as a few historical pics in here. So this was a story I told you about the V1, and they didn't have any electronics in them. But it was feared that they did to start with, but in the end they didn't. They had gyroscopes that worked it. And back to Wooferton. Again, in the drive room, to get the frequencies on the senders, if say you wanted 6 megahertz dead, you'd start with a VFO here. That probably it'll be a sub multiple of 6, so 3, 1.5. It could be 750 kilohertz in the MF drive, and you send that output via the patch panel here to the no, you send the output here to one of these harmonic generators, and then from that there'd be 25 watts of RF that would come out to the patch panel here that would be sent out on the drive lines to the transmitters. You might have 3 of the transmitters on 6 megahertz dead, 6.000. 3 might be on that, and you could use the plugs here to get 3 connections of your 25 watts. So you could send a good 6 or 7 watts down to each sender to start the transmission off with drive. So these are the frequency generating things. 6 VFOs and a spare. But what you'd normally do, if you had 6 different frequencies, you'd use the spare one to set up for the next frequency that was going to come up. Not easy to do. There's no frequency readout. You had to listen to the beats. Excuse me. When I was at Daventry in 1971, these were still in use. The drives, these VFO4s were still in use. Can you hear me? Have I gone?
No, you're still there.
You're still here. Sorry. Yeah, you're still there.
No problem.
Oh, good. I heard somebody shout. Okay. The drives were all in use at Daventry, but we did actually have a frequency counter in the control room, which was brilliant. So you could set them up dead on then to do what you wanted. But in the old days, you had to count the beats. And there was a drive league as well. And Tatsfield in Surrey would measure the frequencies that you were radiating on the carrier. And the TA who was running this would get marks for being as near to 6.125 megahertz as possible. And I think you're allowed to be 20 hertz off in the early days. But it got tighter as the laws progressed. It wasn't easy. There were triple ovens on the drives to keep them really closely thermostatically controlled. And it was quite an art. As I say, there you are. You've got the drive and the harmonic generator. Pick whether you want 3, 4, 5, 6, or 7 times multiplication. The big problem with VFOs like this, say you're on 6 megahertz and you're generating at 750. If you move 2 hertz at 750 and you're timesing it by whatever I'd said, 4 or 5, you go 10 hertz on the output. The error is compounded, which is not good. Makes it much harder. There's the harmonic generator multiplier. You can see the different coil. There's a coil pack there. Can be rotated for what output frequency band you want. ACSP3s, and there's 2 807s in the output there. Classic BBC, homemade, made by the corporation device. Here's Jeff in one of the simultaneous broadcasting, that stands for control position, April 61. And row of jack fields, a schedule here. You can see what's going on. Measuring equipment for audio and various other bits and pieces. That's what it was like. And the phone to London. Come 1963 or 2, the station was re-engineered. This had been prompted by the fact that the history had changed. When it was built in 43, it ran with BBC programme until 1948, when the BBC had got a little bit too much shortwave provision, and it was just about to be closed. But the Berlin airlift had to be got going by the Americans, and the Americans were wanting to broadcast to the Soviet Union, all the new satellite Soviet bloc countries, and they weren't near enough in the States. So they spoke to the BBC, and the corporation basically said, well, you can have it if you want it. It'll become, if you pay for it, you can have it, but we'll keep BBC staff running it. So it became the BBC, it became the Voice of America relay station in the United Kingdom. And if you ever looked at the World Radio and TV Handbook under UK, certainly in the 60s and the 70s, you'd find that the last entry on the UK was Wooferton VOA relay station, Voice of America. So that was from 48 to 60. Again, by 1960, the Yanks were losing interest, and they were just about to shut it. And then they had the Bay of Pigs debacle and Cuba and everything else. And they really wanted to start shouting again to the Soviet Union. And so they took the decision with the BBC that the Yanks would pay for an upgrade. And the plan was to remove 4 of the 50 kilowatt senders, always called senders on shortwave, take 4 of the 4 of the old girls out and replace with 6 250 kilowatt senders, 5 times more powerful. And this was the array switching panel that was used for the 250 kilowatt service. And this was the control room. And you could then view through a window here up the sender hall. And you can see one of the new senders here. This was sender 91. When this was planted there where sender 81 used to be. And the numbers were incremented by 10. The arrays were also incremented. When the station was built, you could be, say, on sender 81, on array 801. And after this upgrade in 63, it became sender 91, and you'd use array 901. The great thing about the numbers were that as the arrays were progressively upgraded for insulation and power handling, when they'd finished it and got to 250 kilowatts, they'd upgrade the number from an 8 to a 9. So if you're on shift, you'd know not to use array 805 on 250 kilowatts. It was only still rated to 50 kilowatts. But when it was upgraded to 905, then it could be used on the new senders. So that's how they progressed that. That's Harry Field in the control room there. Looks like it's fairly rudimentary on heating. There's a space heater there that just plugs into a socket. This is all during a revamp. This was in 1979. They're putting a new control center in at the back here. And obviously they're still working here, and that's why there's wires hanging out the ceiling. But this is actually a picture from 1979, 80, 81, that sort of time. There's a bit of wiring involved, as you can see. That's the back of the old control desk. And here's a mimic panel for the HV, the 11 kV switching that's just been installed. Okay, well, this is what we got after that upgrade in that was the 1963 to 1979 bit. There was a second upgrade then. The first one was the 50 kilowatts to 250. In 1979, the Yanks wanted to put 4 transmitters in and 4 more to add to the original 6. So they paid for another 4 transmitters. These were auto wave change units by Marconi, and they came on the air in 1981. And the control system came on as well to run them. And this control system was called the Watch, Wooferton Auto Control Transmitter, something like that. Wooferton Automatic Transmitter Control for HF, Watch. And here's the VDU for Christmas Day, 16:39:08. So the day shift is just finishing, and the evening shift will be coming in 20 minutes' time. What were the evening shift coming into? Well, on 91, it was on the air on 6060 kilohertz, array 921, 66 degrees. 35V means the program chain from London. The V means it's on Voice of America audio processing. And the next thing that's going to happen, and I can't tell you what the time is because I can't see it on my screen over the right-hand side. But anyway, what's going to happen next is it'll go to 5965 kilohertz on 905, 102, go to off, then something else will happen on the right here. But I can't see that. They're all manual transmitters to tune and wave change. So if you go from 6 to 6, somebody's got to be out there to alter what was then the frequency synthesizer on the bay next to the transmitter. That one just stays the same. This one wants a wave change at some point. 93 is on, it's on 9735, but it's going to be wave changed to 7130 kilohertz, different array. 936 and 917 are both classic arrays for Moscow. They only do that bearing 74 degrees. You can't alter it. They were let's spread it right across the Soviet Union arrays, those two were. That wants a wave from 11710 to 712 manually. So you give you 15 minutes to do that. And that's on the same frequency there. The 80s there, these are automatic. So they'll wave change themselves and tune themselves up. We put the settings in as humans, and it can remember what setting you want. So when you've tuned it up at the beginning of the schedule, you can then recall it as the frequency runs through. So 966, 907, 58, Voice of America, a frequency and array change, 6160, 92190. As you see, the array swap there is on that one there at 1639, but later on, when this one comes off and goes to 5965 on 905, this will be available at 921. Will go across here for sender 81, which itself then will be in that part of the screen, because that's what it will be doing on the present, because this is the preview. This is what's going to happen. Here's a day shift, here's a daytime frequency 15205. 31V is always Voice of America in English, and it means that at a certain time that I can't see, it'll go to 9585, which is VOA, always in Russian on that frequency, because there's the Russian program line, 32V, and there's the bearing for Moscow. So the VOA are on there, 9585, 95375 degrees. So that's Christmas Day and what they had to look forward to. The old transmitters, the 250 kilowatt Marconis, 1963, had big capacitors in the back, smoothing capacitors, paper, and we found that they contained PCB, polychlorinated biphenyl, and so they're all taken out under a plan and replaced with ones from Northern Ireland, from Londonderry, and very successful. That was like for like swap almost, but the crew had to do it. So they're all gloved up and garbed up just in case some of this should leak. But that was the plan on that one. Here's another one of the RCA senders. In the war, they had the box here. The control panel was actually in a little cubicle. That was on the 24th of August, 44. So here's sender 81. And if you remember that picture of Harry Field in the control room, he could look out through a hole in the wall and see the side of sender 91 that stood in its place later. But that's 81. Here's the modulator unit, water cooled. Whether they're the output valves or they might be just the driver valves, so the bigger ones, but they've got lap insulators on, LAPP. That's a trade name of an American manufacturer. And if you'd ever heard about ASPI Distra, the transmitter in the Ashdown Forest that was built in the war, it was constructed by RCA, and lots of it looked very similar to this, with the lap coils and the pipes down to the connections. T3 at Brookman's Park on 908 kilohertz, when I was there in the 70s, had the lap coils as well. Very much an American idea. That was standard telephones and cables, ST&C, but of course, big connections to the States. Okay. Told you that sender 81, 82, and maybe 83 were taken, the old ones were taken away by the RAF, and not all the bits came back. So what they did here, they hadn't got the output section on much of it. So they used a dummy valve one side, Marconi tube one side, and a living one the other, single-ended job to get 50 kilowatts. Wanted a DC filament supply, so they had to get a motor generator for that. And the design was never stable, and being a one-off always provided problems for staff. It's vile. I don't think they minded at all when sender 81 was ripped out in 1963. And here's what replaced them for the second time, when 85 and 86 were taken out in 1979. This is one of the 300 kilowatt transmitters. You've got the RF section behind those two doors, a gangway in the middle here, the control unit here with the modulator tubes around the side, and you've got the manual tune up for it, and then you could press the button there, and it would remember the settings that you'd tuned up as a humanoid. And then you would ask it to go to that frequency, and it would retrieve the settings and come up on the air. Very clever. Plate and screen modulation, a driver tube in there at the bottom to get from 100 watts. There's a 100-watt amplifier. Control is just about here. That fed to a tetrode here that gave about 18 kilowatts into the final tube that was above it. So single-ended design, 300 kilowatts out. And we've still got this one still in service, as is Sender 81. Oh, sorry, I'm telling lies. Sender 83 is now dead. Sender 81, it's the 1970, the 1980 replacement, Sender 81 and 83, both dead, but 82 and 84 continue to live. Antenna field map here. Main building here. You've seen the ones on the Ordnance Survey, 901, 902, 903 on these bearings, then 4 and 5. 920 is still there. 935 is still present, but not in the state that this, at the time this was drawn, this was a 21 megahertz array at 935. It's now on 4 megahertz. And since Skelton was closed in 2012, there was a need for 4 megahertz, and Skelton and Daventry always did the 4 megahertz. But those two have gone, so we had to get a 4 megahertz antenna at here at Wooferton. And the boss said to me just before I retired, if you're going to run 4 megs, where would you put it? I says, do you want to spend any money? He says, no. I says, well, you're only, if you want 114 degrees, which is what you want from Skelton, you'll want it here, and you've not got much choice. So I'd say I'd take the 21 megahertz array out of 935 and put 4 megs in. And that's what they did, because in an upgrade in 2007, they got another set of multi-band arrays here. And this pair here can both do 21 megs. So 930 can do 26 megs. So very useful, that is, to have a multi-band array there. So that freed that up then to do 4 megahertz. The red ones were additions in 1979-80. And you can see 952 that was very near the road here at the front, and they really didn't want to risk it. That's where that tower was. Dismantled 83, so it didn't last long. 53, 54, then don't forget Russia is that way. And they can see where old masts were that were felled to make room for these new ones. And they also put this one in here, 951, and that does transmission southerly on a 20-degree slew. So you've got 160, 140, 180 degrees from this array here. Nothing the other way. You can't reverse these. You can only use them in one direction. I think the antenna field when it was first built was this, like a horseshoe, and then it bolted a few bits on as the years went. This little run here was a later development to give more antennas to get to Moscow and etc. You can see how they've bolted to it over the years. There's a classic array. This is L&M. So this is 924 and 925 as we know it. So the antenna elements, the dipoles are suspended on the wires, and all the mast do is keep it vertical and stop it falling over. HI. So that's a classic shortwave array. The design of that to cut those wires so that it all hangs horizontally and looks neat and is spaced and the curtains are all there. It always amazes me how somebody can sit down and work out all those dimensions to do that exact job, and then fit another one in here, or even a third as you got on 901, 902, 903. No mean feat for different frequencies. Yeah, there you are. 924 is a 17-meter band, and 925 a 14-meter band array. Quick view looking from BB mast. You've got this is the TCI American arrays from the late 70s, 500,000 each, including the masts. You've got the periodic screen here, and then the dipoles on the left hand side. You'll notice just one little thing here I can show you. Here's the wire over the top of the triatic over the pulley at the top of the mast. Comes down and splits to this spreader. Then you'll see the two curtains are hanging from these sections here. But what you will notice is here's the spreader. Just say that's 25 foot across. Just say that. You'll notice that the actual curtains have been pulled together by this section here. And that dimension continues right across the array up to the other mast as well. And it appeared on this one that when they built it, the computer said do 25 foot or whatever. But when they actually stuck the test equipment on, it wanted to be, say, 20 foot. So they had to put it in 5 foot to make it work properly. Now that's space in between the two curtains. Interesting, that one. Here's the output then on the Queen of Shebas, as they're called in the trade by the riggers. Ceramic insulators and knife switches, beryllium copper contacts, and then copper pipe, which is 328 ohms impedance. But this one has not done very well, caught fire and burnt. So what they did here, they took all the metal off and they got a big sheet of PTFE and just used some what's the word for it? It's a bolt with no head on it. There's a word for that. I can't think what it is. So threaded rod, put two threaded rods through and made the connections that way, and that fixed that. Didn't fix the high voltage point, but at least the insulation was good enough to stand in. And that's how they used to do feeder repairs in the old days. Now they use a cherry picker. You have to be a bit more health and safety conscious there with an access zipper now. And this is switch station 1A, screened feeders from the senders. This is 1991, but it was actually built in 1980 for the 10 inputs and the screen feeders that go out. The multiband arrays like to be fed with screen feeder rather than ones that can blow in the wind. And that was and there's four, as I told you at the beginning, there were 4 screen feeders there. But of course, when they took 952 away, there was a spare feeder available. And when Daventry was closed in 1992, we got their test load, which is sodium carbonate in a tank and a pump and a heat exchanger. And if you make the concentration of the sodium carbonate correct, it has a resistance of 328 ohms, which is quite convenient. So you can warm up the sodium carbonate and then take the heat out of it on a plate heat exchanger and use it as the dummy load. So that's what they used 952's feeder for, became the test load. Here's, this brings me back to what I'm doing now. This is sender 82, and it was ripped out. And they were going to put, they then put sender 92 in the same place. And you can see they've put doorways in and they've taken other bits out and made new holes. And that is exactly what I've just done. Been in charge of that project to take sender 93 out from 1963 and install a new sender 93 that's third hand, and it's come from Singapore. It was at Skelton from 2007 to 2012. Skelton was closed. It was transferred to Singapore, the BBC, so they had their station modified to take it, and the BBC have just closed Singapore, so it's been crated up and sent to Wooferton. And as I say, we've taken sender 93 out, and we've done exactly the same things. That we've got rid of all these sort of holes in these places and put some new holes in for what the new sender 93 will need. And that's what they did in 63 with the ones that I've just ripped out. But this is what they look like when they were in before they finished off all the vanity work of the covering here on this cable tray area. So you've got the modulator on the left-hand side, 250 kilowatts transmitter here, RF out. So the RF section's here, and behind the pictures that I can't see is a driver stage to drive this stage here. So you've got a 5 kilowatt driver in at 5 kilowatts, amplified up to 20 kilowatts on the pen stage, then out at 250 kilowatts. Then the audio amplifier plate modulator is here, and that gives about 180,000 watts of audio to plate mod this side. So the 3 units, absolute classic, a classic BBC workhorse, all paid for by the VOA at Wooferton. Risks all taken by the VOA at Wooferton. The BBC said we'd like these. The Yanks said, okay, have them, but we'd never had them before. These were brand new from the production line at Chelmsford. And in fact, 93 that I've just taken out was serial number 101. So it was the first one that Marconi's made with all the extra holes in it. And that's just gone. So they've had the money's worth out of those. But 35% efficient, and the new ones that go in are 82% efficient. So a lot of difference for the same 250 kilowatts. That's what it looks like in colour. January 1984. And another one, that one we have still got sender 95. Get one back of the original 6. So there's 3 down one side, 96, 94, 92 are all RIS. 91's a RIS, and 93 will be a RIS, which stands for Radio Industries Zagreb, and they supplied the new senders. That's the build of 1963, with all 6 being installed by Marconi's. And then through that brick wall are the 2 old RCA transmitters, which were then ripped out in 1980 to become senders 81, 82, 83, 84. The 300 kilowatts went in that separate hall, but they had the job then of taking that blast wall out there, which I gathered was horrendous. It was very well built. Here's Jeff tuning up a driver unit on sender 92. What's that, 1977? And there's Phil Sandel from Ludlow now, G4 HQB. Sandy from Perth, Sandy Ross. He's licensed in Morse, but was a ship's operator, so he never got a ham ticket. And that's one of the final tubes coming out the modulator. No, that's the RF section. This is, you can see the screening on the windows. So that's RF, and that's one of the final output triodes. 125 kilowatt dissipation triode, fill connections on the top, grid ring here, and the anode at the bottom. If you watch TX Factor 29, you'll see all about this. And there it's just about to be lowered. Oh, it's been removed on that one. It's not quite outside yet, but you can see all the RF coilery inside. EEV tubes, BY1144, workhorse, done very well. 3 of these tubes were in the old VLF transmitter at Criggian and also at Rugby, to give on the submarine service GBR and GBZ. They're down at 19 odd kilohertz and 22 kilohertz. Quick view that Wendy took from the top of DD mast. It's now got the local radio on it. Oh no, it hasn't. Sorry, that's the other way around. There's the old tower that was taken down. So she's across the other side of the field on DD mast. You can see the output feeders here. Where the engines were there, where all the emergency stuff was in the war, where the air raid shelter was, and then the front building that was extended in the 1980s as well, and the new restroom at the end there, and the new toilets. So bits were done there. And there was the old feeder to 952 and cut off. That's before the dummy load arrived from Daventry. And then the dishes came. We were privatised in 1997 by the government, sold off. They sold off all the transmission of the BBC. The domestic went to Crown Castle International, and the shortwave went to Merlin Communications International. So they got Ascension Island, Skelton, Radbysham, Wooferton, Hong Kong, all to operate, and the Seychelles. and we're able to do lots of other things, including SAT. And this was a firm from Ashchurch, and they came and put these dishes in. This was the phone service to Kenya. They wanted an input into the UK so they could get onto the BT network for all the international phone calls for Kenya, and they were affected by this satellite this run of dishes. So these were uplinking and downlinking to Kenya, and then we had a few problems with snow, and it wasn't easy explaining to the Kenyans what snow was and why it would cause them so much grief. So there you are. I think that's, as Duncan says, that's all, folks. I'll stop the share.